Hi, I'm Jake Daly.
I'm Dave Van Workum.
Welcome back to episode 2 of FieldFox Fundamentals.
If you missed our last episode, we talked about cable and antenna testing and distance to fault measurements. So you can check out the link right here and catch up. If not, we're moving on to the next episode. Let's get started.
This episode, we're going to be talking about network analysis and more specifically S parameters. And really, you can't understand network analysis without first understanding S parameters.
S parameters are also called scattering parameters, and they're really cool. They're a great way to characterize a device, and what they tell us is the ratio of power transferred between two ports. So traditionally, S parameters are written in the form S with two numbers attached to it. The first number represents the port at which the power is found, and the second number represents the port at which the power originated from. So for instance, S21 is the ratio of the power transferred to port 2 from port 1.
So what we've set up in front of you today is we have two tunable antennas attached to the two ports on the FieldFox. We're going to use S parameters to show that these antennas aren't matched. Clearly they're two different lengths.
Yeah, so we're going to first start out by taking a look at S11 and S22 on the FieldFox. We'll first notice that S11 refers to the reflection present in the antenna connected to port 1, and S22 refers to the reflection present in the antenna connected to port 2. If we look at the screen, we're going to see a graph that is power versus frequency. And we're also going to notice a valley on each of the S11 and S22s that appear in different locations. That valley represents the frequency range at which each antenna reflects the least amount of power. And we'll notice that those two valleys are at different locations for each S11 and S22, which tells us these antennas are indeed unmatched. If we look at S21 and S12, we'll see something interesting, and that's that there's not really a great frequency range at which these two antennas transmit the most power between each other.
So let's see what happens when we match the two antennas. We notice two major things. The first thing that we notice is that S11 and S22 now appear at the same frequency. The second thing we'll notice is that S21 and S12, the transmission parameters, now appear at the same frequency as the reflection parameters S11 and S22. And intuitively this makes sense because you would expect that the frequency at which the least amount of power was reflected at port 1 should be the frequency at which the most amount of power is transmitted to port 2.
We just learned that S21 and S12 are transmission parameters, and S22 and S11 are reflection parameters. We also learned a little bit about antennas and antenna design. So I want you to imagine for a second that you are, let's say, a walkie-talkie designer, and you're tasked with designing a pair of walkie-talkies that can communicate at the largest distance possible. One thing you might want to consider is using two matched antennas. That way, you have a frequency range at which the greatest amount of power can be transmitted between the two devices.
There's a whole lot more information out there on S parameters. We've included a link to an app note in the description. You can also like, subscribe, leave a comment in the comment section, and we'll try to get back to you as soon as we can.
Yeah, so please join us next time as we're going to continue talking about network analysis in the FieldFox. We're going to dive a little deeper into Smith charts and the all-important, all-exciting world of calibration. So, from all of us here at FieldFox Fundamentals, over and out.